Dear conference participants, let us present to your attention a work on the topic Educational Methods of Software Development for Field-Level Industrial Process Control Network System, which was performed as a part of educational process employment when studying a subject of building a distributed automatic control system in Zhytomyr Polytechnic State University last 3 years. The creation of distributed automatic control system is one of modern approach to complex automation, which is based on the wide range of the hardware and technological solutions and methods. New solutions in automation require systemization of knowledge and educational methods to increase the efficiency and time costs of their assimilation and development. When the organization of the modern knowledge database for promotion and industrial network now is a fragment and focused on the specific problems described of in the literature, mainly in specialists of narrow profile. The creation of distributed automatic control system is one of a modern approach of complex automation, which is based in a wide range of hardware and technological solutions and methods. New solutions in automation require systemization of knowledge and educational methods to increase the efficiency and time costs of their assimilation and development. The organization of modern knowledge database for the promotion of industrial networks now is fragmented and focused on the specific problems described in literature, mainly in specifics of narrow profile. All of this requires find a way to systematically modernize teaching methods and tools to improve the speed up the educational process in the field of study. The implementation of last accepted concepts for 4.0 is currently gaining commonly use the characteristics of real and nearest future production. But at the same time, the state of solving even typically automation issues up to individual companies and system integrators. Educational institutions mostly use the industrial 4.0 with a transmission to 5.0 concept model, and the level of abstraction and generalization explain the major benefits. Methodology of the learning the synthesis of automation control system based on industrial networks is not reflected in fundamental literature sources. In the frame of this work, we aim to streamline the work, the subject area, based on the concept of Industry 4.0, systematize and structure the educational materials, combine the new experience of application in production with the elements of educational process. We are focusing on the ideology of the development of Industry 4.0 systematic approach, deep structuring of educational materials, and transferring the latest production experience to the elements of training. Working on the content of general methodology, we divide it into production-oriented phases of creation of knowledge bases. At the first stage, the requirements of the equipment used are formed. This model outlines the object decomposition of the development of distributed automatic control system and includes techniques of measuring of storage and execution control programs, techniques of collecting and processing data, techniques of setting the configurations, techniques of performing of communication, techniques of software part creating and visualization. This sequence of technologies is natural form of complete cycle of decision-making process in industry and needs to be consolidated in the educational process as well. The key part of implementation of industrial network automation system is software, which involve coordinated parallel development processing and synchronization of system variables in real time. The disclosure of component requirements are laid down by the EX standard and supported by the computer-aided software engineering system, well known as like CASE. CASE allow to form a structure approach the implementation of software solution based on modularity, the object-oriented tasks by making templates, standard blocks, general functions, automatic debugging processing, and visual components for guide user interfaces. This makes it possible to facilitate the process of both development and training, creating permanent educational methodology approaches. At the third stage of determining the requirements, the synthesis of automatic control system, the possibility of direct decision of the physical level without a physical connection is important. Simulation and evaluation of operations of reference models allow checking a presence of the system in unusual state as well. Configuring interfaces is a key task in this way. From the point of view of educational methods, the presence of such a stage is a marker which you can conduct situationally analyzing the work of both individual components of the system as a whole system too. Programming is implemented in this stage too and gives better understanding of network connection background. The fourth stage of creation of tuning of the interfaces level corresponding to program protocols and program tasks. Specifying this stage allows you to speed up and commission process between specific communication devices, validate communication protocol, and provide an efficient user interaction model through the development of the object-oriented screen forms and user programs. The splitting into a group to deal with the common tasks and organization a common feedback to estimate the final results and production of network communication are the goal of study methods on this level. As a result of verification and approbation of specified methods, of consideration and teaching of subject materials by evaluation according to the same criteria, carrying out laboratory and practical works with needs of the synthesis on distributed automatic control systems, scaled to production requirements for 20 and 22 years, an increase in in-depth understanding the essence of management processing and skilling of independent processing of subject materials. We achieved increasing of understanding of middle group as a result of stage strategy realization as it's shown in on the diagrams. There was also an increase in success of professional employment through various questionnaires from the side of partner companies in the region. In the same time, the innovative and complex approach used by employers in solving practical tasks was noted. Let us summarize the results we are getting. We proposed methodological basis embedded in the cluster and educational materials and as a skeleton what will allow building a up structure but carrying certain aspects of concrete practical issues regarding to the development of distributed network system of automation control. Half of the present methodology is open to revision and it's not the last resort. Other approaches can be used to improve teaching methods by STEAM technology tools to students who are mastered in automation and computer integrated technologies at the bachelor and master levels. In addition, the survey of employers shown a confident increase in demand for field level automation system specialists. Therefore, the possibility of learning and project development based on paradigms industrial views should be taken into account when formulating curricula for each study program in engineering. The presence of necessary elements in the education for future engineering prevents degradation in industry, avoiding decline in the economy, supporting sustainable development. Thank you very much for your attention. Don't hesitate to ask any questions.